So in part B, we're given that after they exit the device, the particles enter this region of magnetic field directed at 90 degrees to the velocity. In part 1, we need to determine an expression for the speed of particle 2 in the region. We need to express your answer in terms of m and k2. So what we can do here is, for the velocity, we simply have a kinetic energy, and we can determine the speed from the kinetic energy. As we know, the kinetic energy k2 will be equal to 1/2 mv squared. So we simply rearrange this for v. So we get that v is equal to 2 and then the square root of k2 over m. So this will be its velocity. And then in part 2, we need to derive an expression for the horizontal distance x between the locations where particle 2 enters and leaves the region. So what we know is that it will follow a circular path. Therefore, what we need to find here is this circular path's radius. So if it goes something like this, we can find the radius of this path, and this horizontal distance will simply be 2 times the radius. So the way we can find this radius is by considering the fact that the force that is acting on it is the magnetic force, is the only force. Therefore, this will also be the centripetal force, as it's pointing always towards the center of the circle, and it's constant in magnitude. So we can say that the centripetal force is equal to mv squared over r, and this is equal to Q4b, which is the magnetic force acting on a moving point charge. So we can rearrange this for the radius of the path. This will be m times v over q times b. And so what we can say, we can plug in our velocity formula. So then we get that r is equal to, well, the mass of this particle will be m over 2, as we're given in the start. The speed will be 2 times root k2 over m, and it's all divided by 2q. This is the charge of it divided by b0. So what we can say is that the radius will be square root of k2 times m over 2qb0. And since we know that our horizontal distance, delta x, this will have to be 2 times the radius because it will be the diameter of this region here. So that will be root k2m over q times b0.